Hello, this video series is gonna be directed by me. I'm going to study for the OCP exam, which is the Oracle Certificate exam, code 100830, which is this one here. It costs like $300, and you need to have like 68% to pass with 50 questions. It's really hard, and it like stays for 120 minutes, and you have to go do it not online. You have to go do it like actually in real life, which is very hard. Um, and you need to learn extensively for this. Uh, Most people fail for like two times, so like it's like 500 euros just fucking down the drain. Well, let's prepare for it, I guess. Why am I preparing for it? I'm preparing for it because either I pass the exam and I'm Java certified and I'm better than 99% of the market because I have a Java certification, which is hard in a market where there is AI, or or I learn everything and I can pass job interviews without a problem against professional software developers and I can flex on them. I love flexing. Okay. First concepts. First concepts is um okay. What is the GDK? GDK is the Java Development Kit. It's like the kit that you get to be able to make classes, to make to compile, to write code, to get the main system like java.lang imports, etc. What is the JDE, which is what is the GRE, which is it's the Java runtime environment, and this is like the one responsible for running the compiled program. It has the Java JVM, etc., etc. These don't they're not really relevant to know for the exam. There are some commands like javac, which is Java compile. It's a method that you use to convert the Java classes into a class code. You need to remember that at this when you run this, some methods like if you define a class like this, and okay, let's say you go here and you define a main class, which is this, and you say public static void main string args and you do sout hello world. Remember, there is no constructor here, but when you run it, well, in the dash class out file, which is here, why does the class file go here? The class file go here because you are running Java, the command Java, which is this. All this means Java. This is equivalent to this. If you have in your what's it called, environment variables here that Java is located in path. Where is path? Here. That Java is located. Yeah, here. The Java is located in this place. You can just write Java and then write the class path, which is like this, class path, or you can either write D or you can write CP and then write the place where you want the compiled class to go. So in our example, it's out slash, I think it's going to be main, and then no, it's going to be entitled main and then entitled again. I think that's what they use, right? Yeah, look, it's going to the exam OCP, which is this one, entitled, and then to the folder out. So you understand this is the code that is out of our IDE, then production, then entitled. And then when you open it, you'll find in package main, you'll find in package main the the compiled class, and this is a dash bytecode. Like dot class is bytecode, But if you want to see content, there is tools like tools to decompile and see the code in the .class file. So in reality, this code doesn't exist like this. This code is bytecode, but using a tool which is the Fernflower decompiler, you can see the code inside it, and you can see that the compiler has added this constructor while it doesn't exist. So like this is something you need to understand, that Java C inserts some some constructors. If they don't exist, it inserts some access modifiers like the public. For example, for interface, no, for abstract file, for abstract methods, for abstract classes, sorry, it adds public for all the abstract methods if you don't have a modifier, because it's the implicit modifier that it needs to add. So like it auto inserts. This is something to remember because, well, they can tell you if we decompile the class code, what do we get, or etc. etc. Now, to execute a program, you use the command Java, and then you target the class that you want, where the main method is. So the main method is the entrance of your application. There is also jar, which is like a zip. It packages all the files in a folder structure. There is also Javadoc, which generates the documentation of your code based on what you wrote, like this. This is the syntax of Javadocs, and anything inside these two is considered Javadoc. So like if I go here and I write like this, it automatically adds as param args, because args is a argument used as a parameter, and you can go ahead and say args is arguments provided by user in terminal example. Or you can even add another param. If you add another param here, well, you can have like string num like this, and you can add a param num and say num is a random value we added. So like this is something we can do. Okay, and when you run Javadoc, there's Java documentation that runs for this. Since we are talking about comments, this is a comment too, because there is two flashbars, or you can use this as a multi-line comment if you want to. And also, you need to remember what? I think that's it. I think that's it. Okay, now let's talk about a class structure. Let's create some classes and let's talk about class structure. Let's create a class named Python. We will give it a field called public static final version, and then have it equal to no version, and have it equal to 1 by 1. Then create a public int speed example, and it's going to be nothing. And then we create a public, and then we create the constructors. Okay, we create a public Python, and we pass with the speed, and then it sets the speed into speed. Okay, now let's create a method that is public string return version, and have it return the version. And let's have a private int speed calculation that takes the int speed. No, just have speed calculation like this, that returns speed multiplied by 1000 example. And then let's have a protected long real speed, and then have return speed calculation. As you can see, this is a class that has a class named Python that has a static finals field. It has a variable which is a field which is an int of speed. It has a constructor. It has a method that returns a string. It has a private method that is used inside of it to return a real speed example. Okay, so this is a class structure. It has methods, it has every fields, etc., etc., etc. Now, let's say what is next? The next are the main method. Let's create a main method, okay? Let's give a main method to the public class Python. Well, you need to go here, array public static void main string args or you can comment this out and you can write public static void main and then write these like this, or you can even do something like public static void main and then have string like this, args like this. uh, it needs to be public. Here's the important info. The public static, the main method needs to be public because it needs to be accessed by everything. It needs to be static because it's related to all objects, not to one instance, so you can start the program. It needs to be void. Why? Because, well, the main method doesn't return anything, but the arguments can be cited in any way an array can be cited. Because what does this mean? This means that if we run from the terminal, like from here, and we pass in arguments from the terminal, that we can access these variables. Example, if we run Java main Java Python, what package are we in? I think if we run java.main.python and we pass it two strings, we need to be able to print the two strings inside this. So I'm gonna have an example here, which is let's access the argument strings and then print them out. Okay, let's do that. First, we get the var first string equal to args0, and then var second string is args1, and then we s out first string with space second string. Well, if we do this, if we run it from here, it's gonna give us an array out of bound exception. Here, an exception. Why? Because, well, we try to access member 0, but when you run it from here, well, you didn't give any, what's it called? You didn't give any variable. You didn't give anything to the terminal. You didn't give an arguments. So like it gives you that the array is 0 and you are trying is null, but you are trying to access member 0 and member 1. So like it doesn't run, which is a problem because the length is 0. Let's say we run it using the terminal. Okay. Well, I think, give me a second. Okay, let's run it using the terminal. Well, you can compile first, or you can just run Java and take copy the path, the absolute path example, like here, and then we need how many args? We need two, so we pass in Zakaria, and then we pass in Farih, like this. So if you run it, it's gonna print Zakaria Farih here, which is first string plus second string, because you pass in the first argument and the second argument of the array, like this. Okay, now what's next? Well, the next thing is the class structure. Okay, let's suppose we have multiple classes. Okay, let's define another class. Let's define a class named something related to Python, like NumPy, class NumPy, and have this class have public static string public static final string version and have equal to 10.0.1 like this, and then give it a constructor of public numpy, and that assounds that numpy is being used version plus version. Yeah, and that's it. Well, as you can see, we didn't give this a public class. Why? Because when you make it a public class, it becomes a top level class. What is a top level class? A top level class is any class that can exist on its own and be used directly by other packages. If you can only have one top level class per file. Also, a file, a top level class is always public, which means that if you want to have multiple classes in same file, they need one of them has to be public and others to um, need to not be public. Okay, and again, something else, the file name needs to match the name of the top level class, which means since here the public class is Python, we'll remove this so we don't have the error. And since the public class is Python, well, now the name of the file is Python. Yes, you can see that there's two classes here, but this is just an IDE, just something that the IDE sees. What Java sees is that, well, look, we have a public class Python. It's the top level. Well, the name of the file needs to be Python. Let's say we change this to Python Z like this. Well, if we do it, it's gonna suggest it will tell us, well, class Python Z is public, should be declared in a file named Python Z. Okay, let's go back. Um, Let's talk about optional modifiers in the main method. Well, remember, you can even add here, you can add final, or you can add the final here. These are examples. These are optional modifiers. So like if you see in the exam that they use final, well, there's no problem because it's an optional modifier and it mixes well with the static, with the static modifier. I can go ahead and explain why use final in what's it called in main method in Java. Well, here here's why you would use it. Okay, let's say we create. Oh, let's have Java here. Let's say we have a public class A, and then we declare in this a public static void main string args like this. Okay, and let's say we define here a system that println that it says hello from A. Okay, now if we go ahead and have a class B that extends class A like this, we can define our main method again from here and have it say hello from B, right? So class B extends class A, but it defines its own implementation of the main method, which is hello from B. Well, let's try something. Let's say you call a.main. What does this result in? This results in hello from A. Let's say you call b.main. Well, this results in hello from B. Okay, now let's do something like we want to hide the method. We want to hide what it's called. We want to hide the A, for example. We want to hide B. Well, you can use final, the keyword final, to actually hide B. Let's do something. Let's have A equal to new A like this, and have A dot main. Well, what does this result in? This results in hello from A. Now let's have something like B, which is a new B. We create objects using the constructor and call main null. This is going to result in a hello from B. This is hello from A. Okay. Now let's do something. Let's have A and call it B as a new B. Is this allowed? Well, it is allowed. Why? Because B extends A. So any object of type B is an object of type A. So B is of type A. So you can like widen the type. It's like we have string, we have object out of a new string. This is allowed. Why? Because a string is an object. Okay. And then call B as A dot main. This would say hello from B. Okay. Now, let's say we want that all the classes that extend A, when they call main, it says hello from A. What do? Well, we go ahead and do public class A and declare the method as final. When you do this, what does the keyword mean? Keyword final. Final here means subclasses may not hide this implementation. The only main implementation that exists is in A. So like you go ahead and say hello from A, and whenever you want to declare a public class B that extends A, and then you go ahead and do the same thing, which is define a main method, well, this code wouldn't compile. You will get a compiler error when you do this. This results in a compiler error. So this code doesn't compile. Why? Because you are defining your own main method implementation in a subclass of A. While here we have final. So it doesn't make sense. Let's say this class numpy extends Python. Okay. Why did we get an error here? Because it doesn't call super, right? It needs to call super, and it needs to call it with a version. Okay. Let's say we have here a final. This is final here. Final. Okay. Now let's have our own implementation of the main method here. Public string, public static void main string args. Look, main string cannot override main string in main.python. Overridden method is final. See? If you make this not final, well then you can actually implement it, right? Okay, this is a very trick question in the exam. That's why I've revisited it. Normally I wouldn't visit these things because, well, the IDE does it for you. But if you are doing the exam, you need to know all of this. Let's talk about these package declaration and imports. Okay. First, you can have package here. The package declares the name of the package, which is the folder structure that exists. Example, package main declares that this file exists in package main. Then you can import things like what? Like java.util. That what? Import.java.util. That scanner or import java.util.date or things like this. Okay, but as you can see, they are not used here because you don't declare a scanner object, you don't declare a date object. Let's say we have date, okay, and then you can declare the class after. These are optional. It's optional to have the package, okay, it's optional because Java when compiling, Java inserts it for you. It's optional to have imports that are not used. If they are not used, they are optional. If they are used, you are obligated to use them. Now, let's say I'm gonna show a special case. We have public class main, and then we declare public static void main here that gets string args, and then system out the println, and then hello world. What do we notice? We notice that we use system, but system, we don't have it here. We don't have an object called system. So why are we allowed to use system? Well, because Java implicitly makes it available from the java.lang package. So you need to understand that Java lang package is a special package that is auto imported into all classes. And you don't need to specify it, but if you do, it's okay. Okay, so like, look here, if I do java.lang.system, wow, it works. Or I can even use this, the wildcard, and you are good. What does wildcard mean? Wildcard means that you are importing all the direct available classes in Lang. The language is very, very important. I didn't say all the packages, I said all direct classes in Lang. I didn't say all, I said all direct. So if you go to Lang, you can see we have these folders, right? But these are not direct classes. These are direct classes, like abstract string builder, like application shutdown hooks, like boolean, like base virtual thread, like byte, like system. You can see system. Where is system? System here. It's gonna be here. And you can even go and see, well, what is println? Well, println comes from print stream. You can see the implementation here, right? You can see everything. You can see the code, why it's used. It's like 2,600 lines of code only in system. Okay. What is the takeaway here? The takeaway here is that you can import all the classes that directly exist in Lang using wildcard or in any package. You can even import all the classes that directly exist in util using the wildcard, like abstract collection, abstract list, abstract map, etc., etc. But if you want to access zip and you want to get the adler32 or checked input stream, well, you have to do java util.zip wildcard specifier. This only imports all the classes inside the zip folder that are directly available. Remember the keyword directly. Okay. Now, let's say the next problem would be, let's say we have conflict. Okay. Let's say we have a conflict. Why doesn't this? Let's say we have we declare. First, we need to fix up this. We declare a date, right? But then when you want to declare a date, they tell you, well, listen, there is a date from java.util and there is a date from java.sql. What do you want to use? Well, I want to use both. Okay, I'm gonna use the first one, which is this one, but then I'm gonna s out the date, but then I'm gonna define a new date, which is day 2, and then s out day 2. But the difference is I don't want to use this one. I want to use the SQL date. Well, you can use the SQL date by doing java.util dot java.sql.date like this, but it will tell you Java SQL date is already defined. So there's a conflict. How do we do this? Well, you can do this. You can go here and do java.sql.date. And it tells you, easy. We do this. Okay, this constructor doesn't exist. What constructor does it has? Date should be passed a year, a month, and a day. Okay, let's pass it a year, a month, and a day. Okay, good. Now this is a specific import that doesn't conflict with the first one. Now let's say we want to import something else from java.sql. Well, you can use import java.sql.wildcard. And now when the compiler sees this, what does it do? When the compiler sees this, it says, okay, we have date from util and we have date from SQL. It's included here. If you go to SQL, date is included. So like, how does it figure out what to import? Well, it imports the specific one, which is from java.util, and then goes to the wildcard. This is how Java solves conflicts between wildcard specifier and the more specified type of imports. This is how it solves the conflict. Okay. What is next? Let's say we want to use the random class to generate a random variable. Well, you need to import it from here. Let's say we want to import everything from util. Well, we can do a wildcard. We can delete this, and we're good. Are we good though? No, we're not. Look, reference to date is ambiguous. Both java.sql.date and java.util.date match. Why? Because, well, you are importing date from here and date from here, and they are both wildcard imports. So Java doesn't know what date are you using. Well, we can have something like java.util.date. And we are good because we tell Java, listen, if there's conflicts between date, use this one. Unless we specifically have it. And then import the other classes. Easy. Now we talked about wildcards, we talked about redundant imports, we talked about naming conflicts, we talked about creating new packages, we talked about compiling, we talked about compiling into another package, to another folder using the CP and the class path specifier in the javac method. Now we talked about creating objects using the new keyword right here, like here, like here. We talked about creating fields. We talked about a static final field that is a constant. One thing to take care about is like in the exam, they can do something like this. Look, they can come here and say, well, look here. They can tell you public void numpy. Wait, first, numpy is a class. So like, why do I have it like this? They can have it like this and then tell you public class numpy and speed. It's a numpy speed. And then they tell you how many constructors we have here. Well, we only have one because this one has void. So this is a method. This is not a constructor. This is something they use to trick you in the exam. Okay, let's talk about something more confusing. Okay, let's go here and have this. This is named an initialization. Let me write it. Initialization block. It's a block ran whenever there is a new instance of the class. It can be used to set field variables, run setup config code, etc. Imagine as soon as you need to instantiate an object Python, you need to set speed to 5. Well, you can do it here. Whenever a version is run, you set speed to 5. I think this does speed. No, you can remove this dot speed. There's no problem. And you can also S out speed. Now let's say you call a new constructor on speed. What happens? When you call the new class Python constructor, first it instantiates the variables. This is a static variables. It instantiates the static variables first. Why? Because they are constant across all the objects because they are static. So you can call them using the class name only. So first it creates the version, then it creates the speed, which is a variable, and then it runs the initialization block. Let's say this initialization block is here, is at the end. It's not in the beginning. It's here. Well, it's going to search for it. It's going to run this, then go here, run speed, and have speed as 5. Then S out that speed as 5. Then go ahead and call the constructor, set the speed to the new speed, and then you have access to the class. Let's test this out. Let's see if it prints speed as 5. Let's have a Python new Python, and then have s out python.return version, and then run this. Look, it first says that speed is 5, and then it returns the version. Okay, let's add another line. Let's have Python dot return. Let's have new Python at speed 1000, and then print Python dot speed. And let's see if the speed changes. Look, first the speed is 5, which means that initialization block is ran first. Then speed is set to the value in the constructor, which means the constructor is run second. And then the method is returning the real speed and the other calculation. Okay, so you need to understand initialization blocks are blocks that are used to initialize fields, values, do the configs that we need, etc. etc. Let's suppose you have a server and you want every time that you connect that there is something like connection logic to the server. Well, you can insert the connection logic here because this runs in every instance has created of Python. Whenever there is an instance of the object, it runs. Okay. Let's talk about types, data types. Well, the data types that exist, there is int, long, double, float, boolean, char, string. No, these are not data type. Byte. What else? Short. Yes, short. I forgot short. Short. Okay. Each one of these has a type. Okay. Boolean is either true or false. It doesn't have a minimum value. It doesn't have a maximum value, but it has a default value, which is false. And Example of Boolean is like true. This is an example. Byte is an 8-bit integral value, and since it's 8-bit, the minimum value is -28, and the maximum value is 127. What is the default? The default is 0 for it. And what is an example? It's 1, 2, 3. What is a short? A short is a 16-bit integral value. And since it's 16-bit, it's like, I think it's minus 320,000. See, minus 32,000, and between 32,767, the default is 0, and an example would be 1, 2, 3 again. Let's say we have an inch. Well, an inch is a 32-bit integral, so it's very big. It's like minus 2 million. The default is 0, and an example would be this number. A long is different. It's a 64-bit, and it's marked as default 0L. You add the L. That means, okay, this is a long, okay? And when you print it, an example of a value is 123L. Let's talk about float. Float is a 32-bit floating point value. An example would be 0.0f. No, this is the default, not an example. And this is an example. And you can even have a double, which is a 64-bit floating point value. And the default is 0.0 without any letter. And this is an example of it. While a car is a 60-bit Unicode value, and default is barra. I don't have access to the so I'm just gonna copy it like this. U0000, which is character A. You have character A here. Okay. Now, we always use string, but is string primitive? Well, string is not primitive because it's an object that implements car sequence. There is something I noticed while talking. Okay, example this one. Example this one. If you out a float, if you system.print out println float value, the f is not going to be printed. It's going to be 0.0. Here's an example. If we go here and delete all this code and have float val is equal to new float out of, no, let's say float dot parse float args0, and then out float val, and then we go here and we run the Python here like this, and we give it the value 12.0. Well, then when it assounds, it's not gonna assout with f, right? And we can even go here and do something like this, and then print it out, and it's gonna print out without the f. So like if the exam tells you what does this print and it has f, well, it's wrong because it doesn't print the f. Okay, this is an example. Now let's talk about octo, hexadecimal, binary, etc., etc. So to write an octal, it's prefixed with 0. So like it uses octal, which is from 0 to 7, uses 0 as prefix. So like you get var octal value is equal to 0, 17. Well, this is an octal value. This is how you define an octal value. Look here. If you have var octal value is equal to 0, 17. When there is a prefix of 0, this means that this is an octal value, octal integer. Okay. If you want what's it called? A decimal value is gonna be 17 directly, no 0 prefix. Let's say you want a hexadecimal. Well, hexadecimal are 16. So like they are between hexadecimal value are between 0 to 9 and from letters from A to F or A to F, small or big, we don't care. This uses 0x or 0x as prefix. So like let's say we have var hex this value equal to 0x a b 5 example. This is a hexadecimal value. Look here. Or you can have it like this. This is a hexadecimal value too. Okay. Now let's say we want binary. Binary value is between 0 and 1. And to declare a binary value, use 0b or 0b. So example, you can have 0b10, you can have 0b10 like this, something like this. Okay. So var bin value equals 0b10. Now let's say we want to have numbers that are written long number. Let's say we have a number like this is written like this. Oh, you can't because it's bigger than inch. Okay, let's have it should be like this. But it's very hard for us to know, well, where is the millions? Where is the thousands? Well, you can just add underscore and this wouldn't affect nothing. Underscore becomes bad when it's next to the floating point or it's in the beginning. Example, if you put underscore here, this is bad. If you put underscore here, this is bad. Okay? If you have a double example, long double, and you have the double as this, dot this, well, this is a double, right? Because it's just the positions don't make sense, but this is a good double. Let's suppose we put the underscore here. We can't because it's in the beginning. You can't put underscore in the beginning. Let's say we have underscore in the end. You can't because you can't put underscore in the end. But you can't also put underscore here next to the floating point. You can't. But you can put it whenever you want. You can have 3 underscores. You can have 5 underscores. You can have whatever you want. They're just ignored. As long as they are not next to the floating point, they're not in the beginning and not in the end. Okay. I'm gonna explain a very important topic. A very important topic, which is reference and objects. It's a really important topic. Why? Because there's obviously going to be 2 questions or 3 in the exam about this and about the garbage collector. And this is a very hard concept to get. Okay. First we have what is it called? We have the stack and we have the heap. Okay, this is the stack. This is the heap. And this is the stack. Nice. Nice letters. Okay. Now let's say we define a variable. We have variable x is equal to a new string. Hello world. Well, now whenever this object is created with the keyword new, we create a new object which is string out of hello world. Well, this string is gonna be put here in the heap. This is hello world. Now the variable x that references the object is gonna be on the stack. So this references this. Okay. Now you can access the reference using the x variable. And whenever you access x, x is referencing the string. Okay. Now let's say we have in another line, we have x is equal to new string out of hi byword. Well, what happens is we create a new object, which is byword. We delete this reference and we have x here, look here, and reference this one. And since there is no reference to this object has zero reference, the garbage collector is told, listen, this is available for garbage collection. Whenever you are ready, take it if you want. Okay, if he wants. You can't tell him, hey, garbage collector, remove this. You can't. You can call a method which is, I think, gc. What's it called? I need to search for it. Java garbage collector suggests to remove object. Let's have it. Let's have it directly here. I can't remember the method name. Well, the method name is system.gc, like this. This calls the garbage collector and tells her, hey, garbage collector, please remove this object. Well, run the garbage collection process. Look for objects that are not mentioned and remove them. Or you are only suggesting to Java to do it. You are not actually doing it. You are just suggesting to it, and Java is free to do it or not. You can't force this behavior on it. You can't force the Java collector to actually go ahead and collect the objects that are not referenced. No, Java does it automatically, or you can suggest to it. You can just suggest. Okay, Java is a free will, I guess. When an object is available for garbage collection process, an object is available for garbage collection of process if it's not used and if it's not referenced. If there is no reference to it, then it is available. Example, they can tell you same code here. This is line 1, this is line 2, and they're going to tell you in the question, when is the string hello world available for garbage collection? You are going to say, well, it is available for garbage collection from line 1. Why? Because, well, on line 2, this happened. So in line 2, it is available for garbage collection. Okay. Variable scope is something easy. I'm not going to talk about variable scope. I'm not going to talk about class variables. We know, well, class variables exist in the class declaration, and whenever they are declared, then you can access them if they're public, etc., etc. If they're not private, you can't access them. We know instance variables, which are these are instance variables. For class variables, they are like the static variables that are constant, etc. You can access them using the name of the class without instantiating the object. What is a method parameter? Well, a method parameter is provided to the method, like the speed, and you can access it inside the method. What is a local variable? A local variable is something like this that is declared inside the method that doesn't exist outside, but you can use it to have calculations like result int of long number, long double plus long number, something like this. This is an example of calculation that you use the local variables in, etc., etc. Now let's have an exercise. Let's go to main and let's have this exercise, which is this is a very hard exercise, I think, for people that don't know what is a stack. What is first you define one string, one A, and then two string B, and then you say 1 is equal to 2, and then you define 3, which is 1, and then you define 1 is equal to null. Okay, let's see what is happening here. When is 1 available for garbage collection? When is 2 available for garbage collection? This is a bad question. 1 and 2 are not available for garbage collection. It's the strings that are available for garbage collection. Okay? When is the object A available for garbage collection? When is the object B is available for garbage collection? Not the reference. The reference is not the one getting collected because it doesn't exist in the heap. It's the heap that has the memory, that has everything that needs to be collected. Okay. Let's have a new one. Okay. Let's draw. Let's have some drawings. Okay. First on line 7, we have the following one. Let's have 1 references A. This is on line 7. Okay. Now we have 2 references B on line 8, right? And now we have 1 referencing 2 on line 9. So this on line 9, this references this. So like on line 9, there is no connection to A. So A is free. On line 9, A is free. Okay, and then we have on line 10, 3 is equal to 1. So 3 is equal to 1, and 1 references B. So 3 gonna reference B. This is what line? This is line 10. And then on line 11, we have 1 is equal to null. So if 1 is equal to null, this reference is removed on line 11. This reference is removed. So when is A available for garbage collection? A is available in garbage collection since line 9. And when is B available for garbage collection? It's not available for garbage collection because it's still referenced by 3 on line 10 and by 2 on line 8. Okay. Setting 1 to null is only setting the reference that 1 reference is null, not setting that the object is null. No. Okay. When does B go out of the scope? Well, B go out of the scope when the method is finished. Method finished, then there is no reference, then it disappears. Okay, this is uh, this has been the exam. Now I think we can have access to this exam here, to this practice. Okay. Which of the following legal entry methods can be run from the command line? Private static void main. No, it's private, you can't. Public static final. No, there is no return type. Public void. No, this is not static. Public static final void. Good. Public static void. Good. Public static main. There is no return type. Submit answer. Which answer represents the order in which the following? Well, we can have only the class, or we can have package then import in class, which means zyx, like here, or we can have only import and class, which is yx, or you can only have package and class, which is zx, like this. Xz, no, you can't have the class then the package. These are the answers. Which of the following are true? Public class bunny. Well, bunny is a class, and bun is a reference to an object. Main is a reference. No, it doesn't run because name is incorrect. No, you can pass whatever parameter you want. Which of the following are valid Java identifiers? This isn't, because no, this can be. This is good. This is bad because it's a boolean. This is bad because it's a Java class. This is good because public is written with public p. And I think this is bad because it begins with a number. You can't begin with a number. And I think this is good because it's like this. Yeah, that's true. Which statements about the following program are correct? Public class bear, private panda bear, private void roar, south roar, panda bear. Okay. Let's have a new. First, we create a brown bear. The fuck is this? Holy. I'm writing with my. Can we write brown bear BB? References new bear object on line 9. And then you have a PB references a new bear object on line 10. These are different objects. Then you have on line 11, you have brown bear, roar, polar bear. And when brown bear roars using the polar bear, we roar and then we set the panda bear of the brown bear class into polar bear. So like now the PB object, no, now the brown bear object has a reference inside of it, which is panda bear, into this bear on line 11. So now uh, brown bear references this and also uses this on the same line. Okay. Now on line 12, polar bear is equal to no. So this one is equal to no. So it doesn't reference this. So this is removed on line what? On line 12. Okay. And then brown bear is equal to no on line 13. So brown bear is equal to no. So brown bear doesn't reference not this one. So 9 is removed. And even 11 is removed on line 13. And they ask you, the object created on line 9 is first eligible for garbage collection after line 13. What is created on line 9? This bear, the bear referenced by brown bear. This bear. No, this bear is available at line 13. So this is good. And then they ask you about the one on line 10. This one. This one has been removed, the reference on line 11. On line 11, it's referenced by BB. On line 12, the reference is removed to BB. But until line 13, then this BB is set to no. And then this doesn't exist. So on line 13, it's available. Garbage collection is guaranteed to run. No, it's not. Might or might not run. Submit. Good. Good answer. assuming the following class compiles. How many variables define a class method are in scope on the line marked on line 14? Where is the line 14? It's this one. Okay. First, we have a class. We have instance variables. We have initialization block. Initialization block doesn't count because these only exist inside. Then we have two variables, water and air. Okay. Then we have a boolean. Okay, so this is our three variables. Then we have method parameter, which is 4. Then we have the path, which is 5. These exist only on this block, so they don't count. Then you have h, which is 6. Then you have the e, which is 7. Then these don't count, so 7. 7 is the answer. Okay, what is next? Which are true about this code? Choose all that apply. Oh, public class kitchen sink, private int num forks, public int num 5s is out this. Okay. Okay, this is a trick question because this is a multi-block string. It's not a normal string. So all of this is a string. Nothing is calculated. Num forks is going to stay num forks. Num knives is going to stay num knives. So we are going to have cups 0, and then we are going to have includes a blank line. No, there's no blank lines because it begins from here and stops here. Yes, it's going to begin with white space. This one begins with white space. Okay, this is the answer. Good. Which of the following code snippets about var compile without issue using a method? Var spring equal no. No. It can detect var is for the, I didn't mention this. Var is for the LVTI, which is local variable type inference. It's like compiler, the Java compiler detects the type of the variable automatically. For example, if you use var integer value equal to 10, or Java compiler will know 10 is int, so integer value is type int. You understand? This is LVTI. So like one of the rules is that so that the compiler knows what's happening, you need to give it a good variable so it detects what type it is. So when you give it no, it doesn't know what are you talking about. When you give it a string, it knows it's a string. When you have var evening equal no, this is good because this is a multi, it's like they define var evening as an integer and then they set the integer to no. No, can integer be set to no? I forgot. Can an integer be no in Java? Okay, primitive types cannot have no. I'm stupid. Okay, let's go here. Var integer dot value of 3. This is going to give it the integer type, the wrapper integer type. This is going to give it an int, but then it's going to give an exception. This isn't a trick question. This compiles, but then it gives you an exception. This defines multi-variables. Var can't do that. Var can't declare multi-variables in the same line. They can't. It can't do this, and it can't do this. Okay, what about this one? It defines an empty string, then gives the string no. Can a string be no? Yes, because string extends the object. So like, it's an object. So like, it can be no. Okay, let's hope that this is good. Yeah, this is good. For 9, which of the following is correct? An instance variable of type float. Okay, this is a good question. What a good question this is. Let's say we have a class. This is going to be a good question. Let's say we have a class, right? And the Java compiler detects that we are going to use this class. Let's say, example, we will use Python class. What does Python do? Well, Python, when you use the new keyword, creates the new class, right? It creates it on the heap, right? And let's say the class has something like this, like public int speed here, but you don't have any initialization block, and you don't have any constructor speed here. You don't have it. right? So there is no way Java knows what the speed is. But you go here and you define Python, new Python, and then you S out the speed. What speed would it print? I think it's going to print 0. Even though we don't give it no value, it's going to print 0, right? Look, I know. We need to remove this constructor here and run this one. Yeah, it's going to print 0. Why? Because the default value of the int is 0. So what Java does is that for classes, listen, for classes, not for local variables, not for instance variables. No, no. For classes, no. For classes, instance variables and fields, it gives the default value. So on the heap, when it declares a new Python object, it says, okay, give all the fields a default value that are not instantiated, that don't have values, give them a default value so that we can use them and we don't have any problem using them. Okay, this doesn't happen here. Let's say we have an int year and then we assert the year. Well, it's gonna give you a compiler error because it's not initialized. Why? Because this is not done on the heap. This is done on the stack. Here, on a stack. Here, stack. This is the heap. Stack is, you can think about, okay, here is how I think about it. I think about stack as the RAM, okay, or as the memory. It's like something you are doing now. And I think about the heap as something that like you need to keep, like you need to keep because you are going to use a long, like while you are running the program, it's gonna last. Like an object lasts, an object timeline. When does it live? It lives for a long time. But a local variable only lives for that method and then it disappears. So like these JVM initialize these like they initialize them and they take good care of them, because if you don't initialize the values to the default, well, it's gonna give you a problem. If it doesn't give it to you now, it's gonna give it to you in the future. So JVM takes precautionary measures and starts these fields. But if we talk example about the stack, well, if you don't start it now, you are going to face a problem now. So like it doesn't start it for you. It gives you a compiler error and tells you, listen, you need to initialize this value. Otherwise, I'm not going to do it for you. Which is why it tells you here, you need to initialize the variable year. That's an example. What is the next concept? Where were we? We were here. Okay. An instance variable of type float defaults to 0. No, a float defaults to 0f, to 0.0f. An instance variable of type char defaults to no. No, it doesn't default to no. It defaults to the character U0000. A local variable of type double defaults to 0.0. Okay, double defaults to 0.0. But does a local variable default? No, it doesn't. Like we said here, a local variable, this is a local variable. It only exists in the method. So it's a local variable. It doesn't default because it needs to be initialized. So this is wrong. This is wrong too because it's a local variable defaults. A local variable doesn't default. A class variable of type string defaults to no. No, it defaults to, yes, it defaults to no because it's an object. It extends object. We have string, the string class from Java extends car sequence. And then car sequence extends object. And the default value for all objects is no. This is how I like to think about it. So this is wrong, this is wrong. Okay, perfect. Good question. Good answer. Now, this is something like where is the underscore? I said it's next to the pointer to the floating point, so wrong. This is right. This is at the end, so wrong. This is after, wrong. This is not after, not in the end, not in the beginning, right? This is right. This is in the beginning, wrong. Okay, let's talk about this. Given the following class, what is the maximum number of imports that can be removed and have the code still compiled? Okay, look here. Package aquarium, package aquarium. So they are in the same package. Okay, let's say this one doesn't have imports, so 0 here. Let's talk about this one. This one uses public void print. It uses a water object and then souts water. Okay, so we can remove these two because we are in the same package. So here, two can be removed. And like I said, java.lang exists in all Java. So like you can delete these two too. So like you can delete these four. So you can delete 4 imports and you are good. Which statements about the following class are correct? Public class clownfish, int gills, double way, int fins gills. Okay, this is a problem. You don't declare a method like this. So we are going to have this is good. This no. I think line 2 is gonna generate an error because you can't you can't you can't have different types instantiate different types in the same line, can you? Can you no, I don't think so. Can you instantiate different types same line Java? Primitive, I think. I really think this is bad. So I'm gonna say that line 2 generates a compiler error. I know that this gives a compiler error, but so line 4 is gonna give a compiler error. I know the int fins equal girls. So you define fins. So I think this 2 is gonna give an error because this is an initialization block. And the code is not gonna print anything because, well, there's compiler errors. And line 3 is good. Okay, good. Given the following classes, which will can be inserted into insert imports here. So here, and everything can run correctly, right? Yes. We have package aquarium, and we have package aquarium.jellies, and then in employee we use water. What can we use? Well, we can have import aquarium dot the wildcard, which imports the class directly, and then you can use it. So good. And you can import aquarium.water and then aquarium.jellies.wildcard, and then it's gonna give importance to this one because it's more specific. So this is good. Or you can have aquarium.wildcard. So you import all this and aquarium.jellies.water, and this is more specified. So it prefers this one. So this is good. Or you can have both wildcards, so it doesn't know what the fuck to do. So it's not gonna compile. Or you can have the same name class, and then they're not going to run because what the fuck is it going to choose? So this can't be, and since we already have 3 answers, it can't be this one. Good. Which of the following statements of the code snippet starts true? Line 3, a compiler error. Line 4, compiler error. This is a short. Can a long become a short? No, it can't. You need to cast it. Can a double become an int? No, it can't. Can string name be scruffy? Yes, it can. Can we access the length of D? What the fuck is D? It's numpets.length. I think this gives an error too. And I think int E gives an error, which is numgrains. I don't think this one gives an error. I'm going to get an error here. This is not going to be right. So we have an error on line 3, error on line 4. I think line 6 is going to give an error. And I think line 7 is going to give an error because it's length with the parenthesis. not length without parentheses. So, but line 8, which is name, it acts as a string. So like this is good. Okay, good. Which of the following was correction is good? Calling GC is guaranteed. No, it's not guaranteed. Runs on a schedule. No. Yes, it allows GVM to reclaim. As used how? No. Might be eligible, but never removed from the heap. Yes. Another forgettable ones that know if tools are accessible in the program. Yes. Marking for above means never be guaranteed. No. This is not optimal. So why the fuck would Java would do this? Next. What's true about this code? Blocky, squirrel, /s, pigeon, termite. This means that there is a space, and this means that there is no new line. So it's going to be squirrel, space, and then another blank space, and then pigeon, and then in front of it, termite. So it's going to output 2 lines, and it's going to have 1 line with training spaces, and that's it. What lines are printed by following program? Private string brand, this is a class. So if it's a class, these are going to be given default values. So private string brand is going to become no, boolean is going to become false, and float code is going to become 0.0f. But when you print it, it's going to be 0. So as soon as you print it, it's going to be 0.0, which is this one. And when you're going to print brand, it's going to be no, which is this one, not no. And when you are going to print empty, it's going to give you false. So this. No, bro. I forgot. It's no. Okay, I can make mistakes. Which of the following statements about var are true? A var can be used as a constructor parameter. Nope. You need to define what the constructor takes. The type of var is known at compile time. Yes. A var cannot be used as an instance variable. No, it can't. A var can be used in multiple variable assignment statement. No, it can't. The value of var cannot change at runtime. True. The type of var cannot change. What? No, the value can. The type that cannot. Type of a var cannot change at runtime. A var can change. The word var is reserved. No, it's not reserved. For backward compatibility reasons. No, I didn't use this. I forgot this one. Okay, I'm getting I'm getting tired. Which are true about the following code? Var num1 integer dash parse int. The output is 11, max between 11 and B in the hexadecimal. So B is like from 0 to 9, and then A is 10, and then B is 11. So the maximum is 11, and then num1 is going to be a primitive. Num2 is not a primitive. Okay. Look here. About the following class. Public class police box. And then we define string color, long page, public void police box. What? Wait, what? Public void police box? Okay. This is a piège, como una trampa, like they're trying to trick you. This is a trick because this is a method. It's not the constructor. So like when you call this one, you are not calling this one. Well, you are calling the constructor. So these don't do nothing. So these are set to the default values, which are null and 0L. So then you create them with nulls and 0L, and then you access the color in P and you set it to green, and you access the age, which is 1400. Then you go to Q and you say P is equal to Q, and Q we didn't touch it, so Q is null. So now everything is null or long. So blue can't be, 1200 can't be, null, yes, and that's it. Good. What is the output of the following class? Int count. So it starts at 0. This is initialization block, that's a starts count. Then it adds to count. Then we have the constructor, then we have the main method. So what does the main method do? First, it starts 7. So we start with 7. Then it creates a new Salmon object. As soon as you instantiate a new Salmon object, it's gonna print 7, 0, add to the count, make count equal to 4, then print 2. So 7, 0, 2, and then now the count is 4. It's gonna print count, which is 4. So 7, 0, 2, 4. 7, 0, 7, 0, 2, 4. Yeah, 7, 0, 2, 4. What about this one? It says, given the following class, what can we replace? So to make it compile, well, we can use, this is binary, so 0, 1. Okay. This is a long. Can a long be casted to an int? No, it needs to be explicitly casted. This is 0xe. This is hexadecimal. And hexadecimals are from 0 to 9, and then from what to what? From 0 to 9, and from A to E or A to F. It doesn't matter. This is good. This is good. No, this is a double. A double can't be an int. This is a double, but this one is wrong. This is an int binary 0b101. This is good. This is a double. This is good. This is bad. Why is this bad? Why is this bad? Ah, yeah. Look here, look. This is the problem. Because amount is defined within big A, not with a small a. I overlooked it. I overlooked it. My problem. My problem. My problem. My problem. My problem. Okay. Here we define a class river. We define the inch depth. We define temp as a flow. We have a method called flow. It runs a loop, defines an e as the variable, defines depth inside the loop, manipulates depth, makes temp minus minus, which is minus, this is a class variable, so it's accessible. Then assaults the depth, but depth is defined here, so this is an error. So line 10 is going to generate a compiler error, and then assaults the temp. Does line 3 generate a compiler error? Float from double. This is a double. Can a double be a float? I think so. No, it can't be, because a double is larger than a float. Can line 6, does line 6 give an error? No, it doesn't. Does line 7 give an error? No, it doesn't. Would the program print anything? No, because there is compiler errors. Okay, I think I got 2 wrong. Yep. No, I got 3 incorrect. That's cool. GG. I'm gonna see you in the next chapter. This was the first chapter.